In this video, we will look at the LINQ Query syntax in C#. So LINQ, L-I-N-Q, stands for Language Integrated Query. And this query syntax in C# is a very powerful tool that lets you extract information from data sets. The LINQ syntax allows you to write SQL-like queries against any data object that implements the IEnumerable interface. So that means things like lists, arrays, stacks, queues, really any collection of data, any type that allows you to store multiple values can be queried against. The LINQ libraries exist in the namespace system.linq, L-I-N-Q. So if you want to use these LINQ queries, if you want to use the LINQ query syntax, you need to include the system.linq namespace. Let's look at the basic syntax, or the general syntax for a LINQ query. So what we do is we are going to create this thing called a query variable, and this query is going to be of some type of IEnumerable type. And when we do some examples, I will show you what I mean by this. Because the result, the data type of the query can change based on the query itself, using the var syntax in front of the query variable is an easy thing to do, because the type of the query the var will allow the type of the query to be set based on the query itself. All right. So some of the main pieces of a query are as follows. First, we're going to try to select some type of data from some type of data set. The syntax here, the keywords are kind of highlighted a little bit lighter here. From, in, where, order by, select. These are keywords in the C# syntax. The light gray things, data set, filter logic, sort value, these are what we are going to change to try to build our custom query. So the way the syntax works is, if the data set, for example, if the data set was an array of integers, then things would be an integer variable. If this data set were a list of robot objects, then things would be of type robot. So whatever data type is stored in this data set, the things variable is that type of data. Next comes a where statement, where we can build any conditional logic to try to filter out the values in our set. So if my data set is an array of integers, maybe I could say I want to grab all of the integers in my integer array, where maybe the things value is less than 10. So if I wrote things less than 10 here, I would only extract the values in the data set that were less than 10. The order by syntax allows us to sort our results. So if we wanted the results in some type of ascending or descending order, we can add this statement. And then finally, the select statement says from this data set, what pieces am I extracting? Now, if I just have an array of integers, then I'm extracting integers. But if I had an array of objects, maybe I could extract a property from each object. So I can remove a piece from the resulting data set. Once we execute this query, our query result is going to be a generic enumeratable or collection object that contains the subset of data we've just extracted from the larger data set. So our query should be a subset of the data set. We can then build a for each loop that loops through each thing or each value in that extracted data set and do what we want with it. So I think the best way to get some understanding on how this syntax works is we need to work a bunch of examples. So let's do that next. Alright, let's begin with a simple array of names. So I'm going to create a string array named names, and I'm going to initialize it with some name values. How about Anna? How about Omar? How about Jamal? Ty? And how about Lexington? All right, so I have an array with 5 names, 1, 2, 3, 4, 5. These are stored in indexes 0, 1, 2, 3, 4. Now I'm going to try to build a query to extract something from this data set. Now I've included the system.link namespace at the top of my project, so I can use the LINQ syntax. So I'm going to create my query, var query, I'll call it query 1. And I'm going to build this syntax slowly. So first I'm going to say from name in names, select name. Now this query syntax is one line, so I could put it all on one line. It is a statement. It's a statement using these special keywords, ends in a semicolon. But typically, the way LINQ queries are written are each component is written on its own line. And we just put the semicolon at the end. But be aware, this is one statement, one piece of syntax here. So for our first example, I'm going to say from name in names, select each name. So what does this mean? Well, names is my collection, my string array collection. That means name is going to be the data type that is in names. Names is a string array, so name is a temporary string variable. I'm going to grab each name from this collection and store it in the variable name. The select statement at the end says, from the values that I've pulled from the names data set, I want you to hold on to every name, all the names. Now this this isn't doing much useful work. Basically, my query is building the data set itself. Now let me hover over my query 1 variable. My query 1 variable is of data type IEnumerable string. So IEnumerable is an interface that represents a generic collection of objects. So IEnumerable is going to be a generic collection of string objects. Think of it as like a base prototype list. Okay. When we are done with our query, I'm going to say for each string item, no, I'm going to use var here again. For each var item in my query 1, let's print each item. Console.writeLine. Let's just print the item by itself. So whatever type of values are stored in my query, I'm going to grab each thing from my query, store it in the variable item, and print it. So this first example, when I just select name, I should grab all 5 names in the order that they are pulled from the list. And that's what we have. So in my first query, I've just grabbed each individual name from the list in the order that I grabbed them. Not that exciting, but let's look at this select statement a little more. What if I wanted to say select only the 0th indexed value of my name? Names holds a string value. Therefore, name is a string variable. If I pull the first indexed value off of a string variable, I'm getting that first character right here. So if I grab all the names in my names array and I want to select for my query just the first letter of each name, when I print this out, I should just see AOJTL. And I get it, AOJTL. And I could do manipulation on these names as well. What if I wanted to grab the uppercase names for each name in the names array, grab all the names, but I want to save the uppercase values into my query. So when I run this, now my query 1 consists of a bunch of string names that are all uppercase. So just the select statement itself has power. You can grab any piece or manipulate the results of your query. All right. Let's look at the filter syntax. So where some logic is true. The where statement allows me to to filter down the results that I'm grabbing. So for example, what if I wanted to only grab 4-letter names that were 4 letters long? I could say where names, or where name.length is equal to 4. From each name in the names array, from each of these strings, where the length of that name is 4, I want to select those names. So if I add a comment here, I'm selecting only names that are length 4. So when we run this and print it, we see only Anna and Omar are retrieved from this query. So using this where syntax allows us to process and do work on the array. We can filter it down. All right, let's do another selection. Instead of where name length is 4, what if I said I want to filter name, or grab each name where let's say name dot contains the string MA. Oops, don't put a semicolon there. So for each name in names, where the name contains the string MA, I want to select those names. So if I go through this list, I see Omar has MA, I see Jamal has MA. So this should return, query 1 should just hold the values Omar and Jamal. And it does. All right, what might another example be? Well, really, we can filter on anything. If we can imagine it, we can filter on it. So here we are selecting only names that contain the string MA. Let's see if we can come up with one more example. So select all the names. Let's do where name is not equal to Jamal. So here I'm trying to filter out some names. I'm trying to get everything that doesn't match this syntax. So if I want to select all the names that aren't equal to Jamal, I should get Anna, Omar, Ty, Lexington. And that's what I get. So I hope you can see that this LINQ syntax allows you to take a data set and very quickly, in just a few statements, really filter it down. And you can combine syntax too. So I can say where name is not equal to Jamal and name dot length is equal to 4. Well, Jamal wouldn't be 4 anyway, so we'll say name dot length is how about greater than 3. So Jamal would normally be a name with a length greater than 3, but I don't want, I'm filtering out one name, and I want to grab all the other names that have a length greater than 3. So I should filter out Jamal from this first expression, and I should filter out Ty by the second condition. And I only get Ty. Oh, whoops! I said where names were less than 3, so I only got Ty. Let me flip that around. Now we should get Anna, Omar, and Lexington. Okay. So basic LINQ. Oh, let me show you one more piece. Let's look at the order by. If I say order by lets me pick the piece of this the values that are being extracted and sort them in some order. So if I could say sort by name in ascending order, then the results should be in alphabetical order. So before it was Anna, Omar, Lexington, but in alphabetical order they should be Anna, Lexington, Omar. Anna, Lexington, Omar. So if we want our results sorted in a certain way, then we have the power to do that in the LINQ syntax. All right, let's do another example with classes. I want to show building a list of classes, and again show you how powerful this LINQ syntax is. So first, let's build or add to our project a class. This is going to be a very generic class. I'm going to name it a thing class. And inside our thing class, I'm going to model some data. And in the next video, we will talk about data modeling in a little more when it comes to file processing. But all right, this thing class, let's make it have some properties. I'm going to make a public string name, and these will be auto set properties. We're going to do no protection here. So public int quantity, we'll do a get set, and then I will do a public double cost, make it get set, and then let's just provide a couple constructors here. So here's the public thing default constructor, which I'm not going to use, but I am going to make a parameterized constructor. So public thing, we'll make a string name, int quantity, and double cost, and assign each into their property values. So quantity is quant, cost is equal to cost. All I've done here is I'm creating a wrapper for some data. So I want to be able to make a collection of, I want to be able to associate name, quantity, cost with a certain thing. I'm tying these values together. And so I've created a simple class that allows me to very easily create a data type that has these three components tied together. Okay. Now let's go to our program, and we are going to create let's create a list. Let me do a console.writeLine, add some space between our previous example. I'm going to make a list of type things called my cart equals a new list of type thing. Thing should be singular here. So I have a thing thing list. Now let's add 2 or 3 or 4 things to our cart list. So I'm going to say cart.add, and I'm going to add a new thing, and this thing will have a name. I'm going to call it, we'll have a ball. There will be 100 balls, and they will cost 99 cents each. Then to my cart, I'm going to add a new thing. I'm going to add a car, which will cost 10,000, or there will be 10 of them, and it will cost 10,000. And then we will add a new thing. Let's make a, I don't know, a book, and there are 2,000 of these, and it will cost $19.95. That should be enough to do a simple example here. Okay. Now I want to, so I have a thing list that contains 3 thing objects. I want to see if I can query against this list and extract some values. So here I'm going to say var query 2 is equal to from item in cart. Select item. So we'll make it generic at first, and then I'm going to build my for each var thing in my query. Do something with it. All right. Since my cart collection is a list of things, item here is of type thing, and if I hover over it, Visual Studio has determined that item is of type thing. So it is detecting what type it needs to be depending on the collection that you're querying against. So item is a thing. So I can say, if I say select item, I'm going to grab the entire thing in my cart. So here I'm just selecting all the things in my cart. And if I were to print this, I could print the thing dot name, quantity, and cost. Okay, so in my for each loop, var thing is also of type thing. But if I were to say, for example, for each item in my cart, select the item dot name, now my thing here is a string. So do you see how it changed from it was a thing type, now it is a string type, because I am only pulling off the name values from each item in my cart. So if I were to say console.writeLine each thing from my query, let's look at this. So if I run this, I am by selecting only the name components from each item object in my query. when I loop through each piece of my query, I only have the collection of names. If I looped through and selected, if I just change what I'm selecting, if I'm only selecting the cost from each item, when I run my query down here, I should be printing the cost values. And I am. I'm only pulling the cost values out of this query. So again, the select statement is very powerful. It lets me take which component from the query that I want to store into this query. So what data type, what piece am I actually storing in my final output? All right, so let's do some querying here. If I want to get all of the names of items where the price was less than $100, I could say select from each item in the cart where the item cost is less than 100. I want to select the item name. So for each thing in my cart, if the cost of that thing is less than 100, then save its name to my output query. So when I run this, I should only see ball and book. And I do, ball, book. Okay. Now, what if I wanted to say, let's do something else. From, let's see, what if I wanted to only get values? I want the quantity. Let's see. Let's select the quantity of all things that start with B. I want all the quantities of items that start with B. So I can say if item.name starts with a B, I want to grab those quantities. So when I print this out, I should see 100 and then 2,000. 100 and 2,000. All right. Now let's do something a little bit crazy. If my query, let's say I want to do some work, and I want to do some accumulator work across this data set. So for example, what if I wanted to, let's say I want to calculate the total cost of all items that are, I tell you what, I want a total inventory cost. Let's try to calculate the total cost of our inventory. That means I need to multiply the quantity value by the cost for each item in this list. So I'm going to write this down because this is an actual piece of work we could try to extract. Try to write a LINQ query to extract the total cost of all inventory, which is the quantity times the cost for each item. And I want the sum of the quantity and the cost. Okay? So what we can do, I'm going to say var query 3 is equal to, so from each item in my cart, I don't want to filter it in this case. I want each item, so I'm not going to filter it here. But I want to select the item.quantity value multiplied by the item.cost value. So I am selecting I'm taking two values and I'm building an expression and selecting the result of this expression. So query 3 should contain three values, which are this value times this value, this value times this value, this value times this value. Now what we can do is we can say console.writeLine, the total cost of inventory is, we'll format this as currency, and I'm going to insert the query 3 dot sum value. So the sum, the LINQ library also gives us some accumulator methods that are tied to the enumerable type. And so I should get the 3 individual total cost values from each element in my query, and then I should print the sum here. All right, and so it says the total cost of inventory is $139,000, and so right here the car looks like it'll be about $10,000, and then 2,000 times a little less than 20, that would give us a little less than $40,000, and then this is going to add $99. So I think this looks good. So to do a very complex or a fairly complex action against our data set, we did it in, what is this, 3 lines of code. So I'm going to work a couple more examples with LINQ queries in the next couple videos, but I hope this helps.